Hey guys, today I'm going to be talking about topological sorting. So what is topological sorting? It's a linear ordering of a graph's vertices such that for every directed edge, uv, from vertex u to vertex v, u comes before v in the ordering. Topological sorting is not possible if there's a cycle in a graph. It's only possible for directed acyclic graphs, or DAGs for short. Now I'm going to go through the steps of creating a topologically sorted list. What you want to do first is initialize by storing the graph of edges in a GC list. So for each parent vertex, there will be a list of its children or child vertices that they're connected to via edges. Next, I want to create a hash map of the integrity count for each vertex. Integries is basically the number of incoming edges for each vertex. Next, you want to populate the graph. You build a graph by appending the children vertices to the parent vertex, and then you want to count the number of integries for each vertex. You use BFS to find the sources which basically have no incoming edges and their integries are 0, and you store these sources in a queue. Next, you loop through the queue. You pop out each source from a queue and add it to the sort list. You find the children of each source, and you decrement the integrity of each child vertex. If the integrity of a child is 0, or if it's a source, you append it to a queue, and you end this loop when the queue is empty and has no nodes. Now I'm going to be coding up topological sorting. Given a list of lists called edges, I'm going to create a graph. And I'm going to initialize an empty list for each vertex, each parent vertex in the graph. And I'm also going to create integrity count, which initialize as 0. First, I also have to import a deck package to create a queue later on. So I'm going to loop through the edges, and I'm going to append the child vertices of each parent vertex to the graph agency list. And I'm going to increment the degree by 1. Now I want to store the sources in a deck. So looping through the integries hash map, if the value is 0, the degree is 0, then I'm going to append it to the queue. Now I'm going to loop through the queue. Also create the resulting list. I'm going to pop off the node from the queue, and I'm going to append it to the list. I'm going to loop through the children of each node, of each adjacency list of each node, and I'm going to decrement the child vertex integrity by 1, and if the integrity is 0 of the child vertex integrity is 0, then I'm going to append it to the queue. And now return the results. The runtime complexity of this would be O of number of vertices plus number of edges, and the space complexity would also be O of V plus E. Thanks guys.